Today we're going to introduce factoring in algebra. Two of the biggest problems you learn about in algebra are solving equations and solving inequalities. To solve these kinds of problems, you need to understand factoring. But before we talk about how to factor in algebra, let's go back in time and revisit the idea of factoring whole numbers. And to refresh our memory, let's factor the integer 30. In arithmetic, the goal of factoring is to write an integer as a product of prime numbers. For 30, we can write this as 5 times 6. Now 5 is a prime number, so we can't break 5 up into a product of smaller integers. But 6 is not prime. 6 can be written as 2 times 3. So 30 is 5 times 2 times 3. Now these three integers, 5, 2, 3, cannot be written as a product of smaller numbers. They're prime numbers, so we're actually done. So the prime factorization of 30 is 5 times 2 times 3. Now you can write the product on the right-hand side in any order you want, but what you typically do is write it from the smallest prime number to the largest. So this is the prime factorization of 30. And a big result you learn about in arithmetic is that any integer bigger than 1 can be written as the product of prime numbers in a unique way. There's always a little asterisk there that the order of the prime numbers doesn't matter, but if you don't worry about the order, there's a unique way to factor an integer into a product of primes. With this, let's now return to the idea of factoring in algebra. In algebra, instead of factoring integers, we're going to learn how to factor polynomials. Let's see an example. Let's look at x squared plus x minus 6. So this is a polynomial of degree 2, and we call those quadratic polynomials. And I won't explain how, but you can actually write this as the product of two kind of smaller polynomials, if you will, and that is x plus 3 times x minus 2. You'll learn shortly how to do this, but today we're not going to talk about how to factor. We want to introduce what factoring is and why you learn how to do it. So the left-hand side is a polynomial of degree 2, and on the right-hand side, we wrote it as the product of two polynomials. The first one has degree 1, and the second one has degree 1. So if you think of the degree as kind of like the size of a polynomial in some way, what we've done is we've taken x squared plus x minus 6 and written it as the product of two, quote, smaller polynomials. So we factored it in a way. So that's interesting. You know, you can take a polynomial and factor it just like you can factor integers. But what's the point? Actually, we'll get to the point in a second. So let's see another example. Once again, don't worry how I'm getting this done. You're going to learn about that in future videos. Today, I just want to explore this idea of we can factor and what it's for. The next one is x cubed plus 4x squared minus x minus 4. Now, this can be written as the product of two, quote, smaller polynomials, and that is two polynomials of smaller degree. It can be written as x plus 4 times x squared minus 1. And we can keep going. Just like with 30, we factored, first as 5 times 6, then 6, we broke it up into 2 times 3. Here, we can do something similar. We can keep factoring up the parts. On the right-hand side, we have x plus 4, and x squared minus 1 can be written as x plus 1 times x minus 1. So we took a polynomial of degree 3 on the left, x cubed plus 4x squared minus x minus 4. It has degree 3. The biggest exponent is 3. We call those cubic polynomials because when you think about it, a cube is three-dimensional. And we wrote it as the product of three polynomials, all of degree 1. So the idea here is that if you look at more and more complicated polynomials, you will see and learn how to factor those into products of smaller polynomials. By that I mean polynomials of smaller degree. Now that you have this idea of what factoring looks like in algebra, it's different than integers, but similar in some ways, where here we're factoring polynomials into simpler polynomials, if you will. And let's now see what this is used for, why this is important, how we can use this to solve equations and inequalities. And what we'll do first is see how factoring helps you to solve an equation. Let's look at the following equation. X squared plus x minus 6 equals 0. Now on the previous screen, we factored this polynomial, and we factored the polynomial on the left as x plus 3 times x minus 2. So that gives us x plus 3 times x minus 2 equals 0. Now here we're going to look at one of the big ideas in algebra. There aren't many very big ideas, but this is one of them, so I hope you're sitting up straight and focusing. The left-hand side of this equation is written as the product of two polynomials. The first polynomial is x plus 3, and the second polynomial is x minus 2. And here is the big idea. If you multiply two numbers together and you get 0, then one of the numbers has to be 0. So if x plus 3 times x minus 2 is 0, then one of two things must happen. Either x plus 3 must be equal to 0, or x minus 2 must be equal to 0. So here we have two simple linear equations. If x plus 3 is equal to 0, then that means x is negative 3. On the other hand, if x minus 2 is 0, that means x equals 2. So these are the only two numbers for which we get 0, which means our solutions to this equation. X is equal to negative 3 or x is equal to 2. It must be one of those numbers. And the reason why, the big idea and the big reason why this is true is we factored it, meaning we took this polynomial and wrote it as a product. And if a product is 0, you know one of the factors must be 0. The first factor is x plus 3, the second factor is x minus 2, and one of those is only 0 when either x is negative 3 or x is plus 2. So these are the two solutions to that equation. That's how we were able to use factoring to solve this equation. Let's see another example. Let's return to the other polynomial that we factored earlier, and that is x cubed plus 4x squared minus x minus 4 equals 0. So here we have an equation, and we factored the polynomial on the left-hand side as x plus 4 times x plus 1 times x minus 1. So in this equation, we have a product of three factors on the left-hand side. Not two, we have three factors, x plus 4, x plus 1, x minus 1. So if this product is 0, then one of these three factors is 0. And this relies on the fact that if you multiply a bunch of real numbers together, or even a bunch of complex numbers together, if their product is 0, then in there, one of those numbers has to be 0. So we're going to repeat what we did earlier, and that is either x plus 4 is 0, or x plus 1 is 0, or x minus 1 is 0. These three linear equations, if we solve these three linear equations, we'll get the three answers to the equation. And that is x will either be negative 4, or x can be negative 1, or x can be positive 1. So by factoring the polynomial and using the fact that if a product is 0, one of the terms is 0, we were able to find the three solutions to this equation. And once again, this highlights the importance of using factoring to solve equations. And what you will learn in algebra is you'll learn how to factor bigger and more complicated polynomials. But eventually, once you get the hang of it, you will use computer software to do it. Computers are great at factoring polynomials. Now let's see how factoring helps us to solve inequalities. And for this example, we're going to look at the inequality x squared plus x minus 6 is greater than 0. The polynomial on the left-hand side is the one that we factored earlier, and we factored it as x plus 3 times x minus 2. Now, when we were solving equations, we relied on the fact that if a product is 0, one of the factors is 0. With inequalities, we do something different. We look at positive and negative terms. Remember that if you take a positive number and multiply it by a positive number, you get a positive number. If you take and multiply a positive number by a negative number, you get a negative. If you take a negative and multiply it by a positive, you also get a negative. And finally, if you multiply a negative number by a negative number, you get a positive number. So with inequalities, we're not trying to find when it's 0. We're trying to find when it's positive or when it's negative. In this case, we want to know when is the product on the left-hand side positive. That only happens in two cases: when either both factors are positive or both factors are negative. Let's handle both of these situations separately. If both factors are positive, then x plus 3 must be greater than 0, and x minus 2 must be greater than 0. If you solve these basic inequalities, you get x is greater than -3 and x is greater than 2. Now, this is an interesting situation. When is x greater than -3 and x is greater than 2 at the same time? Well, in that case, it only happens when x is greater than 2. So we can simplify, rather than leaving it like this, we can simplify this and just write it as x is greater than 2. So when x is greater than 2, both factors are positive, so their product is positive. Now let's handle the other case, that is when the first and second factors are both negative. That is, x plus 3 is less than 0, and x minus 2 is also less than 0. This only happens when x is less than -3 and x is less than 2. When that happens at the same time. Well, if for a number to be less than -3 and less than 2 at the same time, it has to be less than -3. So here we found another part of the solution. For inequalities, the answers are rarely just single numbers. They're usually whole ranges of numbers, and that's what we found. Whenever a number is bigger than 2, both factors are positive, their product is positive. Whenever x is less than -3, both factors are negative, so their product will still be positive. So this is the solution to this inequality. So let's just recap everything that we learned today. First, factoring is an important tool that you need to be able to solve equations or solve inequalities in algebra. And we use the word factoring because it's a very similar process to factoring integers like you did in arithmetic. Just as you can take any integer bigger than 1 and factor it uniquely as a product of primes, you can do something similar in algebra. The difference is in algebra, you're not factoring integers, instead you're factoring polynomials. And we saw two examples. We factored a quadratic polynomial and a cubic polynomial, but you can also factor polynomials of larger and larger degree. And we'll talk a lot about how I factored these polynomials. Once again, don't worry if you don't know how I did this. That's what we'll talk about in future lessons. And the big idea is that if you have an equation and you get everything on one side and factor, you have a product of factors. And the only way that product is 0 is if one or the other factor is 0. That's how we were able to solve this equation and find that the only two numbers that work, the two solutions, are -3 and 2. And when we looked at the case of a more complicated equation where the largest degree was 3, we then factored and once again used the principle that if the product of the factors is 0, one of those factors must be 0, and that gave us the three solutions to this equation, -4, -1, and 1. And inequalities were different. We still had to factor, but now, instead of trying to find which factor was 0, we were looking at the signs of the factors. And we reminded ourselves that you look at the product of two positives, a positive, negative, positive, or negative and negative. And then we were able to find the solution by looking at what must happen for both terms in this case to be positive or both terms in this case to be negative, because those were the two ways you could get a product that was positive. And that gave us a wide section of solutions. So that is the importance of factoring. That's why you'll spend a lot of time learning how to factor, because it helps you to solve equations and inequalities. And once you get the hang of factoring and you know what the process involves and what the solutions tend to look like, then you can kind of graduate and start to use computer software to assist you in this process so you can solve these types of problems more and more quickly.